Good afternoon, respected teachers. It's me, Faisal Rajregmi from DC6. My student ID is NP03A1909290. I'm here to present on Naive Bayes algorithm. In this slide, I have included the formula of conditional probability. As Naive Bayes algorithm uses Bayesian technique, which is completely based on conditional probability. So let's move forward to today's agendas. Today's agendas, we have introduction, general overview, problem definition, why we need Naive Bayes algorithm, and history behind Naive Bayes algorithm, an example of pseudocode, complexity analysis which contains best case and worst case, the application of Naive Bayes algorithm, its limitations, and finally conclusion. So without any further ado, let's move to introduction. What really is Naive Bayes algorithm? Naive Bayes algorithm is completely based on Bayes theorem. Bayes theorem uses Bayesian technique, and as I said earlier, Bayesian technique is all about conditional probability, and it has application in exploratory and predictive modeling. What is exploratory and predictive modeling? This can be a question. So exploratory modeling is a research methodology that uses computational mathematics for complex and uncertain systems. And predictive modeling uses statistics to calculate the probability of a sample. And Naive Bayes algorithm uses Bayesian techniques, excluding the dependencies. Excluding the dependencies meaning Naive Bayes algorithm focuses on individual datasets and assumes the datasets to be independent. And Naive Bayes algorithm has been thought to be computationally less intense than any other algorithm, as it does not involve any complex programming. And Naive Bayes algorithm quickly generates mining models. Mining models are used to represent data such as regression or classification. And Naive Bayes algorithm applies to SQL Server Analysis Services. SQL Server Analysis Services is an online analytical platform which is used for data mining. Let's move to problem definition. Here I have included some points on why we needed Naive Bayes algorithm. Real-time prediction. It is fast as it does not involve any complex programming, as I said earlier. So it allows for making predictions in real time. Predictions can be made easily using Naive Bayes algorithm. Multi-class prediction. We don't have only one classes or data sets, we have multiple classes or target value. So multiple target values can be predicted using Naive Bayes algorithm. Spam filtering. Spams are unnecessary emails, and sometimes they can be a threat to our security. So Naive Bayes algorithm has been used by many companies like Microsoft and Oracle to identify spam emails. Sentiment analysis. We as a customer might not always be satisfied with the services provided by the developer on different apps. Naive Bayes algorithm can be used to analyze the positive or negative sentiments or comments of the customers. Recommendation system. Naive Bayes algorithm uses data mining and machine learning to filter unseen information. Data mining is a technique which is used to identify the different patterns in multiple data sets, and it has been widely used in machine learning. let's move to the history of Naive algorithm. So it was named after statistician Thomas Bayes, 1702-61. The assumption from second half century and of 18th century says it came from strong naive assumption. Naive meaning lacking worldly judgment or knowledge. But after the death of Thomas Bayes, his friend Richard Price edited his work and presented it in 1763. So it was officially announced in 1763. However, the American statistician, so this is the rank given by the statistic board to statistician, he argued that it was discovered by Nicholas Sanderson before Bayes. So it can be seen that Thomas Bayes is not only the pioneer for naive Bayes algorithm, it was also put forward by Nicholas Sanderson, and it was developed for fast and highly scalable model building and score. Moving forward to the pseudocode. Here I have included an image of pseudocode for naive Bayes algorithm, and it says read the training data set, calculate the mean and standard deviation, or calculate the likelihood for each class, get the greatest likelihood. Likelihood meaning we can only find likelihood when we calculate the probability of a sample. So with reference to this pseudocode, I have taken a simple data set which shows whether and going shopping. The answer is either affirmative or negative. It can be seen in the following table. Moving forward, what we really do in naive Bayes algorithm. Step 1. We make frequency table. Based on the data, we create a frequency table and tabulate the data. From the previous table, we can analyze the number of no and the number of yes and show it in the given table. Step 2. In step 2, we make a likelihood table by calculating the probability of each weather condition and going shopping. So in this slide, the probability calculation has been shown. The probability for sunny is shown to be 5 by 14, that is 0.36 based on the previous data set, and for overcast it is seen that it is 4 by 15, 0.29, and for rainy it is 5 by 14, which is equals to 0.36, and the total probability for yes is 0.64, while the total probability for no is 0.36. In step 3, we calculate the posterior probability using naive Bayes equation. Posterior probability is also known as conditional probability, and naive Bayes equation is the formula of conditional probability. So let's look at a problem instance. A girl will go to shopping, so weather is overcast. Is this statement correct? So using the probabilities calculated from the table, we have to analyze whether this statement is correct or not. So for this statement to be correct, we calculate the probability of yes, and for this statement to not be correct, we calculate the probability of no. It has been shown in solution for calculating the probability of yes. So the probability of yes, we calculated the probability of yes, and then we put it in the formula of conditional probability, and similarly we can calculate the probability for no, and if the outcome of yes comes to be greater than no, then the statement is correct, otherwise it is not correct. Moving forward, let's go to complexity analysis. For complexity analysis of Bayes algorithm, I have taken the following analysis. So we might have n number of features and k number of level classes. We do not know how many classes and how many features are there. In this case, we need to calculate probability for n and k. So the worst case comes out to be O and k. Moving forward, best case. In best case, I might also be naive because I think I lack some research for this complexity analysis. Although I have taken or given example from what I learned from the internet. So for best case, suppose we have only one data set, then we do not have to go through n data sets. We do not have to go through a long process to calculate the probability, and we can find the probability in single step. Hence the best case comes out to be ON. Moving forward, there are many applications of Naive Bayes algorithm. It allows easy and faster prediction of test data sets. As Naive Bayes algorithm uses probability, we can know that it is widely used in predictions. The probability is all about making prediction. The event might happen or it might not happen. And test data sets are specifically designed for computer. So assumption of independence can also be performed in better way compared to logistic regression. The main difference between logistic regression and Naive Bayes algorithm to calculate the probability is logistic regression. It is known as a complex method, and it is a linear classification method which is used to calculate probability. Whilst Naive Bayes algorithm is simple algorithm which calculates the probability easily compared to logistic regression, and it performs well in categorical input compared to numerical variables. Categorical input means those input having names such as the color of ball, red, black, blue, name of an animal, etc. So it has been known to perform well in categorical input as it is easy to understand. As everything has its pros and cons, Naive Bayes algorithm not only has application but it has limitations as well. So there comes a problem known as zero frequency. What is zero frequency? Suppose in categorical data sets we have a data set which was not observed, and the probability that Naive Bayes algorithm calculates is it comes out to be 0. So we cannot make any estimation or assumptions if this problem persists, and it is also known as bad estimator. Why this is known as a bad estimator? Because Naive Bayes algorithm calculates the probability according to the independent events. So the probability calculated by Naive Bayes algorithm can't always be thought as the best probability, and we cannot depend on the probability calculated by this algorithm. And it is almost impossible to get the set of independent predictors, meaning the data sets or events might not always be independent, they can be dependent in some case. So finally, let's move to conclusion. From the previous slides, what I have been able to understand is that Naive Bayes algorithm is totally based on probability and assumptions. And there are various categories of this algorithm. And it has been known that a Naive Bayes algorithm has different categories. The one that uses normal distribution is also known as Gaussian model, and the other is known as multinomial, which is used for discrete values. And as the name naive suggests, it is a technique which may not be thought as the best technique or algorithm. However, naive model or algorithm is tremendously appealing as it is robust, it does not include any complex programming, and it is a simple algorithm. So this much for today. I hope you liked my presentation. I hope it was helpful to know something about my Bayes algorithm. Have a great day ahead. Thank you.